In this video, we're going to talk about mass-to-mass stoichiometric conversions. So let's remind ourselves the steps to calculate any stoichiometric problem. Step number 1 is to correctly balance the equation. Step number 2 is to convert the given amount into moles. Step number 3 is to set up mole-mole ratios. And step number 4 is to use those mole ratios to calculate the moles of the desired chemical. And step number 5 is to convert the moles back into the final unit. I know this sounds like a lot or looks like a lot, but in reality, it's going to come down to maybe 3 brackets at most. And step number 1 is usually done for you. So let's do some example problems and I'll show you how easy this is. So if I have 6.5 grams of aluminum and that reacts with an excess of oxygen, how many grams of aluminum oxide are formed? So I'll be nice and give the equation to you here, but eventually you'll have to do some of these on your own. So here's the balanced chemical equation that is described above, and as always we're going to start with the one piece of information that they give us, 6.50 grams of aluminum, and we want to convert that into grams of aluminum oxide. So our first step, our first bracket, is to always convert into moles. So we set up a bracket and we want to convert 1 mole of aluminum. We want to convert those grams of aluminum into moles of aluminum. To do that, we need to divide by the molar mass. So in 1 mole of aluminum, we have 27 grams. That's right off the periodic table. Grams of aluminum will cross off with grams of aluminum. And if I stopped here with this math, if I did this math, my answer would be moles of aluminum. And that would be a wrong answer because the question's not asking us for moles of aluminum. That's how I know I need to keep going and keep setting up other brackets. So our next bracket, our middle bracket in any stoichiometry problem, is always the mole-mole ratio step. This is a very important step. This is going to convert us out of aluminum. We want aluminum to cross off here and here, and we want to turn it into the chemical that they're asking us for, in this case, aluminum oxide. So we go to the equation and we see there are 4 moles of aluminum for every 2 moles of aluminum oxide. So we write it like this. This way, moles of aluminum will cross off with moles of aluminum. If I stopped here, my answer, the unit, would be moles of aluminum oxide. That's close, but I don't want moles of aluminum oxide. I want grams of aluminum oxide. That's how I know I need to do my third and final step to convert to the final unit. I want to convert from moles of aluminum oxide into grams of aluminum oxide right here. So I'm going to put moles of aluminum oxide on the bottom and 1 mole of aluminum oxide. I want to figure out how many grams I have. So to do that, I need to go to the periodic table, maybe set up a little chart like this. Aluminum oxide contains 2 aluminums and they each weigh 27. So 27 times 2 is 54. It has 3 oxygens and they each weigh 16. So 16 times 3 is 48. If I add those two numbers together, I will get 102 grams. Okay, so now moles of aluminum oxide will cross off with moles of aluminum oxide, and I'm left with grams of aluminum oxide, exactly what they are asking for in the problem. That's how I know I'm done with my brackets, and I can punch this into my calculator. Remember, when we're doing math like this, we multiply by everything on the top and divide by everything on the bottom. I like to go left to right, and of course we can skip the ones because it won't change our answer. So in my calculator, I will press 6.50 divided by 27 times 2 divided by 4 times 102, enter, and that would be 12.3 grams of aluminum oxide. Okay, let's do this next one. If 10.1 grams of iron are added to a solution of copper 2 sulfate, how many grams of solid copper would form? Go ahead and pause the video and see if you can write out this equation on your own, using everything you've learned from Chapter 9 and everything you learned from Chapter 11. You should probably recognize this is a single replacement reaction. You should be able to figure out what these formulas are and what the products are. So go ahead and pause the video when you're ready. I'll show you what it is. Okay, here's the formula when it is correctly balanced. How'd you do? Okay, so if you can't get this far, you have no chance of getting the problem right because your mole-mole ratios will be wrong. But the good news is most of the time I will give this to you in the problem. I'm really testing your ability to do stoichiometry this chapter, but you should be able to do formula writing and product prediction and balancing equations. Okay, so we want to find out how many grams of solid copper would form if 10.1 grams of iron react. So step number one is always convert to moles. So 1 mole of iron, according to the periodic table, weighs 56 grams. So grams of iron will cross off, and that math would convert us to moles of iron. Next step is to use our mole-mole ratio. This is what's going to get us out of iron. I want iron to cancel off and turn it into copper. So there are 3 moles of copper for every 2 moles of iron according to our balanced chemical equation above. So now moles of iron and moles of iron cross off and I'm into moles of copper. But I want grams of copper. So I need to do one more step and convert from moles of copper on the bottom, and 1 mole of copper, according to the periodic table, there is 64 grams of copper. Now moles and moles of copper cross off. I'm left with grams of copper, what they're asking me for. So it's time to punch it into my calculator. 10.1 divided by 56 times 3 divided by 2 times 64 is 17.3 grams of copper. So let's summarize what we've learned here so far. Whenever you do any stoichiometry problem, follow the 5-step approach to solving stoichiometry problems. The first bracket, we're always going to divide by the molar mass of the starting chemical. This step is going to convert us into moles. The second bracket is your mole-mole ratio step. Remember, you want the moles of what you have to cross off and go away and turn it into the moles of the type of chemical they want you to solve for. The third bracket is to multiply by the molar mass of the chemical that they're asking you for. Doing this is going to convert from moles back into grams of your desired product. Remember, always write your units and cross off above and below to make sure you're setting it up right. If your units cross off and you're left with exactly what the question's asking you for, chances are you're going to get the problem right. If you skip this step, I promise you you're going to make mistakes and get some problems wrong. So don't be that person.